Welcome back. So we're talking about electrical, and I'm now going to talk about my approach to labeling and stapling. So I like to label all of my bays in all of my boxes on what circuit they are, and then in the case of switch boxes, I've got all of the switch numbers, so 68, 69, 70, and then on the top I'm marking what they actually do. And I've got an Excel spreadsheet that's got all of the circuits. I've got an AutoCAD that's shows where all the wiring goes. And then I also mark the individual cables to where they're going to go next, or where, in the case of, say, the end of the line, I mark where they've come from. But so this one says it's going to S72, which is, I know, over at the French door exit from the dining room, and it's for the three-way for the barbecue pit. Anyway, so that takes care of labeling. The next thing I like to make sure I do, and this is, a lot of electricians aren't going to really care about this, but it's important for the insulators. And that is when you have a cross bay cable, to make it as horizontal as possible. And what that does is it allows the insulators to slice the insulation so that it's going to fit tightly around here. If it's like this, it's a lot harder to get a nice tight fit, and that is going to dramatically change your R value of that section. If the insulation isn't tight to the stud sides and to each other on the seams. So I always make sure that I have a nice horizontal line. Now, for stapling, I am using the Delta 20 volt stapler, and this is an absolutely wonderful tool. It's brand new. Ask your inspector whether or not they're going to allow it on the project. Mine did. And it comes with these sticks of staples. And the beauty is, obviously it's mechanical, so you don't have to be hammering, and it fits into really tight places. But it automatically adjusts the depth based on the size of cable that you are stapling, and I have no idea how it works. There's obviously something in the mechanism that it can sense between how far that's pushed back and whether or not that is on the surface of that you're stapling to. And it is designed for, I'll just give you an idea here, single and double cable of 14.2, 14.3, 12.2, 12.3, even 10.2. It's designed for a double stack cable. Once you get up to 10.3, which is the maximum it can do, you can only use a single cable. That's its limitations. This is all for copper. And it's like I said, it's a wonderful tool. Obviously the staples are more expensive than the metal ones that you hammer in, but you save so much time. So for instance, I've got a 2-conductor and a 3-conductor, and it's just simply a matter of deciding what I want on top, what I want on the bottom. It's going to automatically turn on the light when it senses that it's in a good spot. Done. And you are finished. This plastic, call it sleeve, is not meant to go to the stapled surface. All it's there for is to prevent chafing from the sheathing on the cable to the metal on the staple. Now, let's talk about movement. A lot of forums where I looked at various electrician comments, they did not like this because it doesn't tightly staple the cable. It's not supposed to tightly staple the cable. It is actually against code to have a staple so tight that the cable does not move as it's doing here. If you staple too tight, you are propagating a stress point on the cable, on the conductor at that point, which can overheat and eventually lead to a fracture and a failure. So you're actually supposed to be able to move your cable in and out of the staple. And one of my first inspections I had with my inspector while I was doing my rough-in for the soffits, I needed to close in the soffit, so I had him come and look at the cabling I had done. And the first thing he checked was, he said, okay, good, you haven't overdriven your staples. Now, at that point, I was using the standard metal staples. I didn't have this beautiful beast. But he said that was the #1 thing that he looks for. So anyway, let's just, again, in BC, I think it's every 56 or 58 inches that you need a staple. So technically I could have one at the top, but to provide a little bit neater, I'll just put in an extra one. And that does provide, it allows the movement. It's still going up and down without chafing, but it keeps the cable in a spot that I want it. Now the reason that you want it, there's two reasons to allow it to move. One is, as I said, you don't want a stress riser created. You don't want to overly compress that copper inside the conductor. But you also want flexibility. The whole point of the staple is to hold the cable in the general location in the stud bay so that it's free from mechanical damage of things being attached to the wall on each side. And the reason, the second reason you want it to be flexible is if you drive a nail in or a screw in here and it starts to miss, the cable will move out of the way. If it was super tight and it couldn't move at all, you would end up scoring the outer sheathing and most likely the inner conductor sheathing and hitting the copper. So that's some of the tips that or tricks that I've picked up from Inspector and online research. Building science is where I get this information from. And as you can see, it's super easy to use this tool. Ask your inspector whether or not he's going to approve it. It is brand new, so it's not necessarily common anywhere, and the inspectors might not be used to it, and therefore they might not approve it. But fortunately mine did, and I absolutely love it. I will talk to you again soon.